Hello, welcome friends. Me Anila. The topic of my discussion is about combustion of linolenic acid. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you how to detect unknown compound. In this video, I will tell you how combustion of linolenic acid occurs and we can detect linolenic acid. Linolenic acid is an organic compound. It is a fatty acid, means it contains carboxylic group and carbon chain. When this fatty acid is burned in the presence of oxygen, combustion occurs and carbon dioxide and water is formed. So with the help of combustion reaction, we can detect the compound. Example, a compound containing carbon, hydrogen and oxygen is combusted. Zero point 0.5 gram sample gives 0.4851 gram water and 1.421 gram carbon dioxide. Molecular weight is 278 gram per mole. Find empirical and molecular formula. We have to detect unknown compound. Amount of sample is given. Am- An unknown compound contains carbon, hydrogen and oxygen is combusted. Amount of sample is given. Amount of water formed is given. Amount of carbon dioxide formed is given. And molecular weight of unknown compound is given. We have to detect the compound by empirical and molecular formula. Solution. First, we will calculate carbon, hydrogen and oxygen moles in the organic compound, unknown compound. For this, we will calculate first moles of carbon dioxide. Moles of carbon dioxide is equal to amount is given 1.421 gram divided by 44 gram per mole. 44 gram per mole is the atomic weight of carbon dioxide. After solving, moles of carbon dioxide is 0.0323 moles. We have calculated moles of carbon dioxide, where 44 gram per mole is the molecular weight of carbon dioxide. Because carbon has 12 atomic weight and one oxygen has 16 atomic weight, so 16 plus 16 plus 12 is equal to 44. So 44 gram per mole is the molecular weight of carbon dioxide. We have calculated moles of carbon dioxide. Now 1 mole carbon dioxide contains 1 mole carbon. So 0.0323 moles carbon dioxide contains 0.0323 moles carbon. So we have calculated moles of carbon. Now moles of water. Moles of water is equal to amount of water that is already given 0.4851 gram divided by 18 gram per mole, which is the molecular weight of water. After solving, moles of water is calculated to be 0.0269 moles, where 18 gram per mole is the molecular weight of water. Now we have calculated moles of water. Now we will calculate moles of hydrogen. 1 mole water contains 2 moles hydrogen. So 0.0269 moles water contain. We will multiply 0.0269 with 2 and divide by 1. We get 0.0538 moles hydrogen. Now we have calculated moles of carbon and moles of hydrogen. Now we have to calculate moles of oxygen. Amount of carbon. First we will calculate amount of carbon, amount of hydrogen, and after this amount of oxygen, and then moles of oxygen. So for amount of carbon, moles of carbon 0.0323 moles into 12 12 gram per mole is the atomic weight of carbon. The amount of carbon is calculated to be 0.387 gram. Amount of hydrogen, we will write moles of hydrogen 0.0538 moles into 1 gram per mole is the atomic weight of hydrogen. So amount of hydrogen is calculated to be 0.0538 grams. We have calculated amount of carbon and hydrogen, and we have also the amount of sample already given in the example. So for calculating amount of oxygen, we will subtract amount of hydrogen and carbon with 0.5 grams. That is, amount of oxygen is equal to 0.5 gram minus 0.387 gram minus 0.0538 grams. After solving, amount of oxygen is 0.0592 grams. So we have calculated amount of oxygen. Now we will calculate moles of oxygen is equal to 0.0592 gram divided by 16 gram per mole is the atomic weight of oxygen. After solving, mole of oxygen calculated to be 3.7 exponent minus 3 moles. So we have calculated moles of carbon, hydrogen and oxygen. Now we will apply mole ratio. Now carbon is to hydrogen is to oxygen. So we will write moles of carbon 0.0323 moles, moles of hydrogen 0.0538 moles, moles of oxygen 3.7 exponent minus 3 moles. So we will divide all these three values by the smallest value, which is 3.7 exponent minus 3. We will divide by 3.7 exponent minus 3. We get moles of carbon 8.73, moles of hydrogen 14.54, moles of oxygen 1. Because 8.73 is approximately equal to 9, so we will write 9. And 14.54 is approximately equal to 15 and 1 is equal to 1. So the carbon, hydrogen and oxygen ratio comes 9 is to 15 is to 1. So this is the empirical formula. Empirical formula means the simplest formula. C9H15O is the empirical formula of unknown compound. Now we have to calculate empirical formula weight. For this, we will calculate empirical formula weight. 9 is the number of carbon atom into 12 is the atomic weight of carbon plus 15 is the number of hydrogen atom into 1 is the atomic weight of hydrogen plus 1 is the number of oxygen atom into 16 is the atomic weight of oxygen. After solving, empirical formula weight is calculated to be 139 gram per mole. So we have calculated empirical formula and empirical formula weight. Now we will calculate the value of N. For the value of N, there is a formula which you have to memorize. N is equal to molecular weight divided by empirical formula weight. We will put the values. N is equal to 278 gram per mole. This is molecular weight of unknown compound that is already given in the example, divided by empirical formula weight which I have calculated recently, 139 gram per mole. After solving, the value of N is 2. Now apply the formula. Molecular formula is equal to N into empirical formula. You have to memorize this relationship. Put the value of N2 into empirical formula C9H15O. After solving, the molecular formula is calculated to be C18H30O2. So we have detected the compound. Compound is linolenic acid containing 18 carbon, 30 hydrogen, 2 oxygen. We have calculated empirical formula, simplest formula and molecular formula or actual formula of linolenic acid. So we have detect the compound by combustion. Linolenic acid is a fatty acid, organic acid. It reacts with oxygen to form carbon dioxide and water. With the help of amount of carbon dioxide and water and with the help of molecular weight, we can detect the compound by combustion. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.